All right, y'all, we'll go ahead and get started. Thank you, all of you, for being here today for today's Data at Your Desk workshop, Introduction to MATLAB. My name is Dr. Nick Roosh. I am the STEM Data and Research Librarian here at Florida State University Libraries. And before we get started with the workshop content, just a couple of quick housekeeping items. We do ask that throughout the workshop today that you keep your mics muted and cameras off when you're not speaking. If you would like to participate, follow along, ask questions, we welcome you to use the chat feature in Zoom. Or to raise your hand. Emily is here from the libraries as well. She'll be monitoring the chat and will be alerting me to when there's questions or answering questions as she is able. All right, and as we get started, I'll just make sure, do a quick check. Can everybody see my screen? Thumbs up, thumbs down, yes, no. Awesome. Great. All right. All right, so just a quick overview of what we'll talk about during today's session. I'll give an introduction to MATLAB itself, a little bit of background about the software. We'll talk about the interface, so sort of the home screen or interface of MATLAB, and we'll go through some definitions that will help us throughout the presentation. We'll talk about working with variables, extracting matrix data. We'll talk about importing data into MATLAB. So if you have a data set externally, how to import that into MATLAB, and then how to create some 2D plots from that data, do a little bit of analysis there. And then depending on time, we'll finish up and we'll talk about doing scripts or using something called scripts in MATLAB. So just a little bit about this workshop, sort of what we will cover, what will not. I sort of like to lay some boundaries beforehand. So today's workshop is going to be a very introductory workshop about MATLAB. We'll sort of talk about the basics of the interface, some MATLAB syntax, and then, as I mentioned earlier, how to do some sort of basic data analysis within MATLAB. This workshop is not a formal introduction to coding and programming. There will be a little bit of coding that I will do throughout the session, but MATLAB is pretty user-friendly in that you don't always need to use that, and I'll talk about that as we go. We also, just due to time, won't have time to necessarily deep dive into more specific MATLAB applications. There's hundreds, maybe thousands of functions and commands in MATLAB, along with a lot of different plotting methods. It's a very robust software, and we will not have time to review all of them today, but I will show you some resources for how to get more information on those if you have more project-specific questions after today's session. So just before I really dive in, I just wanted to do sort of a quick poll. How many of you have used MATLAB before, have either seen MATLAB, maybe you used it a little bit a long time ago, but it's been a while, just to sort of get a feel for the room. If you wouldn't mind dropping that into the chat, that'll sort of help me as we go along today. All right, great. So we have a little bit of exposure, sort of looking for, a refresher, getting back up to speed with it. So hopefully this, the stuff we talk about today should do that. Thank you very much. All right, so just a little bit about MATLAB. So MATLAB is really an acronym that stands for Matrix Laboratory. It's a numerical computing environment built around the MATLAB scripting language. It was developed in the late 1970s by a mathematics professor from the University of New Mexico, Cleve Moeller. And Moeller's students went on to form a company called MathWorks, which now offers MATLAB as a commercial product. And so MATLAB currently has millions of users worldwide. It's primarily used in the areas of science and engineering. It does have some uses in economics as well. It allows users to perform matrix manipulations, plot functions and data. You can also implement and develop algorithms. And the software was originally developed and is still good for interfacing with programs developed in other languages, including C, C++, Fortran, and Python. Some advantages to using MATLAB. MATLAB has an extensive built-in analysis functionality. So with some data analysis programs, to use certain applications, to maybe plot something, you need to download different packages for that, such as with Python or R. There's tons of different packages that you need to download to interface and use some of those functions. MATLAB has a lot of that already built in. So it's already in one spot, which makes it really, really nice and easy to find. You can implement and test algorithms easily. Sort of going along with the built-in analysis functionality is there's dedicated toolboxes within MATLAB for specific use cases and specific calculations that you might be trying to do. I think, and then the last two I think are really important. MATLAB has extensive help documentation. So the folks that make MATLAB over at MathWorks are really great about providing a lot of resources for using MATLAB. There's a lot of help documentation built into MATLAB using the help command. And you'll also even see that automatically pop up sometimes when you're typing functions. And also, I believe MATLAB has a relatively easy learning curve, at least compared to some other data analysis softwares that are out there. As one professor put it, MATLAB has engineering power without needing to be a software developer. So as I mentioned, there's a lot of features that make it fairly user-friendly. If you've used really any sort of word processor, use Microsoft Excel or any similar program, then you'll be able to at least pick up on some of the basics of MATLAB after some practice. So as I mentioned earlier, MATLAB is a proprietary software. We do have it available here in many spots at Florida State University. But once you leave Florida State University, if you're somewhere that doesn't have access to the commercially available portion of MATLAB, there are open source alternatives. And this one I show on the screen is one example called GNU Octave. This is a free open source alternative to MATLAB. And it runs most MATLAB syntax. It has a lot of the same built-in plotting and visualization tools. It's compatible with many MATLAB scripts. and runs on several different processing systems like Linux, Mac OS, Windows. So this is also an option if for some reason you don't have access in the future to the MATLAB software. I will mention here at Florida State. Florida State has an institutional license to MATLAB, so it's available both through the MyFSU Virtual Lab, which is what we'll be using today. It's also on library desktop computers, if you're able to access one of those, through the scientific desktop, and some departments also have licenses as well. All right, so for today's workshop, I have a couple of example data sets that we're going to be used. I've pulled some data from the two sites that are linked here on the screen. And I've put those in a Google Drive that's at this bit.ly link. And you'll all be getting the slides, everything to this after today's workshop. So you'll be able to go back and use these again, use the data sets that are in here. I'm going to escape from here. All right, so it should be in a Google Drive such as this. You'll see there's a few different versions in here, but we'll be using this commute data 2015-2018 and the C19 cases 2020-0706. So these are here if you would like to follow along while I'm doing the examples and doing some of the data analysis. All right. And so for doing that, if you want to follow along and use those, the first thing you'll need to do is download those to your own computer, save them somewhere on your computer. There should be a download button that comes up on Google Drive. And then, since we're using the MyFSU VLab, we'll need to upload that data to there. So first, how do we get to the MyFSU Virtual Lab? If you've never used it before, I usually just do a Google search for FSU Virtual Lab. You get this MyFSU VLab. And then you get this screen. You can sign in. And then it'll ask for your FSU credentials, your ID and password. All right, and then this is the home screen. So you'll see there's several different software programs available through the MyFSU Virtual Lab. This is really great if you're working remotely or you're off campus and need access to some of the software that FSU makes available. There's a lot of Adobe programs. There's quite a few data analysis programs as well. And you can also favorite any of these as well if you use these often. You'll see I have MATLAB here favored. It's the only one I have right now, but you'll see this on your home page once you log in. All right, and then I'm going to open it. So it's going to take a minute or two probably to load. All right, is everyone with me so far? Awesome. Sweet. All right, so if we go back, so this slide has some instructions for importing data to the MyFSU VLab. You can find this information on the MyFSU VLab site or on this slide if you need to come back and reference this. So we've signed in, we've opened MATLAB, and then if we look, there's this little, sort of this little 3-barred icon here at the top that when you hover over it, kind of turns into like a 3/4 circle shape type thing. If we click on that, it gives you more options. So it gives you option to go full screen, download, upload, multi-monitor if you have more than one monitor. But for today, we'll want the upload icon. So this little cloud icon with an up arrow. So if we click on this, so now you just go into your PC, find the data. So I find, I'll just use this as an example. So if you click open, if you find your data sets, you'll get this other pop-up window. And for this, I'll use libraries, documents, documents. So there's 2 documents. And then there should be a little MATLAB folder. And so then we would just hit OK. So again, it's up here. Go to upload, find the data, click open on that window, and then in this window, this should be the sequence. And then you would just hit OK. Right, and I already have it in there, so I'm going to cancel that. All right, and so then you'll see later when we go to actually import the data and use it within MATLAB, we'll be able to go to that folder. If you're using MATLAB on a desktop, you wouldn't need to do that sequence. You would just download it and save it to your desktop, and then you'd be able to import the data directly from there. Since we're using this sort of online platform, there's a few extra steps. All right, so I have some other slides here, but I'm going to go into the MATLAB interface for a little while and just demonstrate some of the things here. I'm going to use this CLC command, which clears my command window. All right, so the first thing I want to mention is the MATLAB interface. So when you first open MATLAB, this is the interface you're going to see. I will note this is the 2016 version of MATLAB. They come out with a new version of MATLAB really almost every year. So I think the latest one is maybe 2019. I don't know if there's one for 2020. Most of them are pretty much the same. Most of the commands, functions are exactly the same. The layout will sometimes change slightly, and they might add a new feature or two. But for the most part, they're pretty much the same. So this is the 2016 version. And I'll point out a couple of things that you'll notice when you first log in. So this first one is the command window. This is your primary space in MATLAB where you're going to define functions, type in different commands, define your variables. And those variables, when you define them, will get listed in this workspace over here on the right side of the screen. So if you define, say, variable A, variable B, C, all of that will get listed over in your workspace. So that allows you to keep track of, the different data that you've put in, the different variables and functions that you've defined in this particular session of MATLAB. Over on the left-hand side, you'll see this current folder window. We won't focus too much on this today, but this window shows you what directories or file paths are available for working in, which can be really important when you're working with multiple data sets at once. We're not going to worry too much about that today, but I just wanted to point that out for those of you that might be using MATLAB in the future for research or a project. So MATLAB looks at all variables in terms of matrices and arrays. So as mentioned earlier, MATLAB stands for Matrix Laboratory, so it would make sense that they're looking at everything. It looks at everything through the language of a matrix. And there's a few different definitions that we'll want to talk about. So one of those definitions is a scalar. So a scalar is a single value. So otherwise, you can think of it as a 1-by-1 matrix. A vector is a collection of numbers in one dimension. You'll either hear the terms row vector or column vector. So row vector is essentially a horizontal matrix. So you have one row with n number of columns. A column vector is you'll have one column with n number of rows. And if you put those together, you get an array or a matrix, which is a collection of several values of the same type. All right, so some tips when working with variables, and then I'll show y'all how we define variables in MATLAB. All variables should have a name or a value associated with it. So like A, B, a letter of the alphabet. It can have a text name, something like that. That will allow you to keep track of the different analyses that you're doing. If you don't define your variables, MATLAB's just going to provide a generic variable for it, and it's going to be the same generic variable each time. So it'll just keep overriding it, which I'll show in just a second. Values can be assigned to a variable with the equals operator. A variable can have an alphabetical or an integer value. So you can have a numerical value. You can also have a text value as well. And decimal values can also be assigned to a variable. So if you have the value of pi, for instance, you can use decimal points when you are defining variables as well. All right, so this is where we'll go back into MATLAB. So to define a variable, let's say we want to do variable A. And let's say we just want to make A equal to 5. So we're just doing a scalar, so it's one value. So we can just type into our command window, A equals 5. And you'll see it outputs that in MATLAB. It shows us that A is now equal to 5. And then in our workspace over on the right-hand side, you'll see that it has the name of the variable, A, and then the value is 5. If I were to just say type in like 20, for instance, without defining it, you can see that MATLAB just gives that a name as ANS or answer. And if we do that again, what you'll see it does is it once again uses that same sort of generic name for the variable, ANS, and then it overrides that in our workspace. So that's important to note about your workspace, is that if you use the same variable for something, MATLAB is just going to take the most recent definition. So if you were to say like A is equal to 4, it's going to redefine A is equal to 4. So that's really important to keep track of if you're working with a lot of different variables. And it's why we mention, sort of having definitions for each of those. All right, now if I want to start writing some matrices or doing some vectors, for a row vector, we're going to use either spaces or columns. So let's say we have a variable C, and we do the equals. And for defining an array, so a numerical array, we're going to use these sort of square brackets. That's what MATLAB uses to sort of designate row vectors, column vectors, and matrices. And so to define a row vector, you can either use commas or spaces. I'm going to use commas just to keep things consistent. And when you're done defining your matrix, you'll want to make sure to close your brackets and then hit enter. So now you can see we've got a 1×3 matrix with values 2, 4, and 6. And that now appears in our workspace on the right-hand side. If we want to do a column vector, let's say we define that with variable d, again, square brackets. This time we are going to use semicolons between our values. So if we say want a 3×1, type in your values, semicolon between each, close your square brackets, and then you'll see it has defined that on the screen within the command window, and then it's present over in your workspace. And then finally, if you want to do a matrix, let's say we want to do a 3×3 matrix, so 3 rows and 3 columns. We can sort of combine the two that we just did. So we can use commas to define our rows. In between each of our rows, we can type a semicolon. Then when we're finished, we close our brackets and then hit enter. And now you can see we've defined our matrix. So we have each of our rows, which we've used the commas in between, and then semicolons to space those out. All right, is everyone with me so far? Awesome. Sweet. All right. So now we're going to talk a little bit about extracting data or extracting values from matrices. So now that you kind of know the basics, you've seen how we define our matrices, how the MATLAB language works, at its most simplest level. Now we'll really get into sort of looking at the basics of data analysis and how you can work with these different values within MATLAB. So for this part, I'm going to actually clear my command window. So if you want to ever clear your command window, if things are getting a little messy, you have a lot of values, but you want to keep the values in your workspace, you can type this CLC command. If you want to get rid of any of the values in your workspace, for that you would use this clear command, and you can type a specific variable name, or if you want to clear all of them, you would type in clear all, and that'll clear out those variables. So for example, if I just say I want to clear that answer, that A and S value, I can type in clear A and S, and you'll see that is now gone from the workspace. So I'm going to leave those variables up there for just a few minutes. We'll clear all that out here in a little bit. But now I'm going to define another matrix. So if I give this, say, value X, so now I'm going to do a 5 by 5 matrix. And this one's going to be really simple. I'm not going to get too deep for this one. This is just an example to kind of demonstrate how to extract specific values, specific portions of information from your matrices. Keep it nice and simple. All right. So we defined a 5 by 5 matrix as having equal to variable X. You'll see here in the workspace, it has X. Since it is a larger matrix, it just defines this as a 5 by 5 matrix here. All right, so there's a few different ways you can extract information depending on how much you want, how many values you're wanting to extract. So let's say you want to just extract one value, right? So if you just want one value in this matrix, just by looking at it here, you can sort of see here, this is a fairly small matrix. But this could be really useful if you have a much larger data set that you're working with within the software. So say I want to pull the value in row 3, column 4. So to do that, I'm going to define that value as y. So I'm going to set y equal to the variable x. So we have our function x that we are pulling from. So this is telling us, where to pull from. And then I'm going to define 3, 4 with just these regular parentheses. This will direct MATLAB to pull the value from row 3. So row is the first value, and then column 4. So you can see it pulls the value 14. And if we go to our third row, we look in the fourth column, you'll see that has the value 14. If you want all the values of a particular row or column, we can use the colon marker. So if we say define a variable z, say we want all the column values from row 5. We can take x, and then we want row 5, comma, all of the column values. So that colon is going to mean all in this case. If we just have the colon by itself, it's going to pull all column values from row 5. So then you'll see it's taken out all of the 5th row. If you want to do the exact opposite, and you want to say pull all of the, say you want to pull column 5, you want to pull all of the rows, type in all the row values, so use your colon from column 5. You can see each time you define that, it's going to output that in your command window. You can also extract portions at once as well. So if you want more than one row or one column, if you want a portion of the data set, but maybe not all of the data, you can do that as well. I think we're up to maybe like G at this point. So say you want to pull from rows 2 to 4. So say you want to pull all of those values, you can do 2 to 4. So here, our colon is essentially telling us we want to pull all of the information starting in row 2, going to row 4. We want to pull all of the column values from those rows. So we've pulled those out. And if we want to do something analogous, say we want columns 3 to 5. So say we want those last 3 columns. We can use H is equal to X. So we want to pull all of the row values from columns 3 to 5. And you'll see if we go up, it has pulled those last 3 columns. So those are just some really fairly simple but really powerful functions and commands to learn. This will be especially useful if you're working with larger data sets, if you need to use portions of the data to maybe plot some of it to make some sort of a visualization, as we'll do here in just a little bit. All right, is everyone still with me? Does anyone have any questions? All right, awesome. All right, so I am going to now clear out our command window and our workspace just to make things a little bit cleaner. So we'll use our CLC command, and then I'm going to clear all. So clear all of those variables out of our workspace, and then CLC. We're going to be putting some data, importing it into the window, so want to leave enough space so that all of that is clear. All right, so now we're going to look at importing external data files. So we've sort of learned how to work with matrices within MATLAB, how to extract different numerical values, different data points. Now let's try our hand at a couple of different examples. So this is where we'll use those example data sets that I mentioned earlier to upload the data directly into the MATLAB interface. So I will say before we do this, I had a couple of specific file types within that Google Drive. So this was essentially a CSV file. This was an Excel file that I uploaded into Google Drive. MATLAB supports a lot of different file formats. And you can find all of those on the MathWorks website, which I'll show at the end of the presentation. There's really a lot of different options for importing data into MATLAB. So to do that, you would go up to the toolbar up at the top. You'll go to this import data. So this little green down arrow button. So if we click import data, it's going to come up with the files. These are all the files associated with MATLAB here that we're using on this online system. So if you remember earlier, I saved this under documents and then this MATLAB folder. You'll see I've done this presentation before, so I have other data sets that are already in here. So for this first one, I'm going to want this commute data 2015-2018. So if I click this and then I hit open, It's going to think for a minute. There we go, it's coming. Sometimes it's a little bit slow. All right, so this should open up a new pop-up window. Can you all see this pop-up window, by the way? I know that sometimes Zoom has issues with pop-up windows. Okay, y'all can see that. Great. Yeah, if there's a case where you can't see one of those, just let me know. I know sometimes it works and sometimes it doesn't within Zoom. So, all right. So it should open up this little pop-up window. And this shows a preview of the data that you're importing. So you see here, I had two different tabs. So I had the original data. So this is like average commute times for a few different states, and then for the United States overall. So I pulled this portion of the data, and then the second tab is that data simplified. So I've essentially taken those states, broken it down into the average time for each year in minutes. So we've got the different states at the top, and then the US as a whole at the end, and then the different years. So this is what I'm going to use as an example as we're importing data and we're doing some plots. So you'll see a few options up here at the top for how you want to import the data. You can select a range, so you don't have to select all of the data. You can just select a specific range, and you'll see that changes up here at the top. I actually want all of this in this case, so we'll make sure all of that is highlighted. You can download it a few different ways. You can download it as a set of column vectors, as a matrix, as an array. We're going to do it as a numeric matrix. You can also change this name right here. So this is essentially the file name. Sometimes it'll add an extra few values, few letters to that name. But I'm going to simplify this a little bit, which you'll see why here in just a couple minutes. So we're just going to call it commute data for this example. And then finally, you can select how you want to import it. The easiest is just to import data. You can also generate a script or function if that is useful for working with the data in your case. But for this example, we're just going to click this import data. All right, and you'll see then it says the following variables were imported, commute data as a 4x5 matrix. If we look back in MATLAB, you'll see in the workspace, it has commute data. So it's named this particular variable after the file. And it's a 4x5 matrix. I always like to check just to make sure it pulled all of the data in correctly before I start doing any sort of work with it. So to check that, you can just go to the command window and type in the file name. So just type in commute data, and then you'll see, hit enter, and you'll see it imported all of our data. It did this thing here. You'll see where it's taken all of our data and it's got all of the numbers at the top now multiplied 10 to the third, 1 to the third, or 10 to the third. It's the same data. This is just based on the settings for MATLAB. But you'll see, since I typed in commute data at the top, whenever you are defining something where you need to use that variable, you have to type in that file name, which is why I sort of simplified that from before. So if you had that long name from earlier, you have to type that in every time. So just a little quality of life type thing to sort of help things move a little faster. All right, so now that we've got this data in, go back here for just a second. And the first thing we're going to do is create line plots. So as you'll see, there's a lot of different plots you can create with your data in MATLAB. Probably the simplest and most straightforward one that you'll see is a line plot. These allow you to compare sets of data or track changes over time. These can be in either 2 dimensions or 3 dimensions, and there's a couple of examples here on the slide. You can plot them using either linear or log scales, and you can plot expressions or functions over specific intervals. So going back into MATLAB, so the first thing we need to do once we get our data into MATLAB is we need to define our variables. So say we want to do an XY plot, so a 2-dimensional line plot. Well, first we need to define what X is and what our Y values correspond to. So in this case, I'm going to want the year on the bottom. So remember, the year was this first column over here at the left-hand side. So if we say X is equal to commute data, and then we want all of the row values in column 1. And in this case, I'm going to put this little semicolon after the function. And so you'll see what this does is it defines our variable. So it still defines X, but it suppresses the output in the command window. And this can be really, really useful if you have hundreds or thousands of values and you're trying to do data analysis, right? So, the more data that you have, the more that it's trying to define and analyze, the longer that's going to take if you have to output all of those values. So using that semicolon will suppress that output in the command window, which will save you a lot of time and computing power. But it'll still define it over in your workspace. Excuse me just a second. All right, so now we want to define our Y value. So our Y is going to be our average commute time in minutes. And if you'll remember, we had 4 different sets of data, right? So we had 3 states, and we had Florida, Georgia, and Alabama, and then we had the United States as a whole. So if we want, say, a separate line for each of those, right? If we want to plot 4 lines, we'll need to define 4 different variables for those. So I'm going to, for this notation, just use Y1, Y2, Y3, Y4. And so for the first one, I'm going to set Y1 is equal to commute data, and then we'll want column 2. So that would be our first state, and then Y2, commute data, in column 3. And you'll sort of see where this is going. We're going to get those last 2 variables in there. Make sure you spell it right, or MATLAB will be like, what are you doing? So now we've defined our variables. You'll see that over in the workspace. We've got those in our command window. So now we can start plotting our data. So this is the fun part. So first thing I'm going to do is we're going to define this figure 1, and this is going to essentially open a window where our plot is going to go. MATLAB, if you use the plot command or any sort of command that plots your data and you don't do this, it'll still plot your data automatically, but it's going to give you a very generic Figure, same thing earlier. If you just keep plotting something without defining a figure, it'll just keep overwriting your first figure. So this is helpful if you want to do multiple plots within the same session. So I'm going to define that figure 1. And I'm going to say plot. So if we just want to do a line plot, it's very simple. You just use the plot command. Why they assigned the generic plot command to a line plot, I'm not sure. They did that probably when they first started with MATLAB. It was probably the first type of visualization they did. And it's one of the more common ones. And you'll see I kind of stopped here, but this is that help feature that I mentioned earlier. So you'll see it's got this nice little pop-up window that's come up that says, well, you've done this plot feature. So here's all the different options for that. And if you want to know what one of these is, you can actually click on it and get more help for that. So it sort of tells you what it is, what situations you might use it in. So this could be really useful if you're not exactly sure, you want to try multiple functions for plotting your data. But we're just going to use the plot xy. So if I say x, and we're going to say y1, so we don't have anything that's just y. So if I say plot x, y1, and then I hit enter, if you go back to our figure pop-up window, and I'll ask again just to make sure. Can everybody see this figure pop-up? Awesome. Thank y'all. So you see it's just plotted our one line, right? So it's just plotted that first set of data. If we want to get more than one line on the same plot, we use this hold on command. So if you type hold on, and now every time we use this plot command, it's going to plot another set of data points onto our graph. So if we say plot xy2, xy3, and xy4, and we go back to our figure, you'll see that it's plotted all 4 lines onto the same graph. So all 4 sets of data points are now present on one plot. And once you're done plotting all of the data on one graph, you can type hold off, and then that'll take off the hold that you've put on that plot. So anything you would do afterward, if you would do a new figure, would go on to the next one. All right, so that's getting the data plotted onto a figure. Once you get that on there, there's several different things you can do to manipulate that data, to make the graph look nice, adjust the axes as necessary, whatever you need to do for your particular analysis. And what I like to always start with is this insert drop-down menu. So you'll see it has a place to put an X label, a Y label, a title. You can insert a legend as well if you want to, define those different lines that you've got on here. They're in different colors, so you can define what each of those are, which is very helpful if you're looking at these later on, or if you're putting these in a publication or a presentation or something like that. So I'm just going to label our X and Y axes. You'll see it comes up down here. It's kind of small. We'll go year. And then if we insert on the Y side, this is time in minutes. And then we can insert a title here at the top, say commute time in the Southeast United States. All right, and then for legend, we can do legends actually a couple different ways. I'll show you both. So for this, if we just click legend here, it's going to come up with this little legend box. And it's just going to come up with this, data 1, data 2, data 3, data 4. So it doesn't have like the different states, right? That we were pulling from earlier. You can type these in manually. And what's nice here is that it actually has pulled these in the order, going left to right that we imported the data. So like data 1 is Y1, data 2 is Y2, Y3, Y4. So if you remember, what states corresponded to each of these, and I'm going to cheat a little bit because I have this written down. So they use Florida, Georgia, Alabama, and then this last one was the United States overall. So if you look at this, now we can actually look at that data and see that this blue line corresponded to Florida, this purple line, the US as a whole, etc. You can also change this axis down here or on the side if you'd like. You'll see when it did our tick marks, it did like half years here, even though we didn't have any data points for our half years. You can go in and change those. We'd like, I'm trying to find, it was under here. All right, so if we go down to insert axes, it's thinking about it. What else can I do? Come on. All right, well, you can go in and you can change, your tick marks to, get rid of those half years if you were going to put this into some sort of a presentation. All right, so the other thing that I want to do, oh, I did not want to do that. All right, so we can also do our legend by using the command window. So to use the command window, we have to use something called text arrays. And that's essentially very much the same as we were doing earlier when we were doing numeric matrices, except this time it's going to have text values in them. So to do that, we're going to use this labels function. And to do that, we're going to say labels is equal to, since we're doing text arrays, we use this little squiggly brackets instead of the square brackets. Then if we type in Florida, Georgia, Alabama, US, and you'll see with each of these, I put the like one, so one quote instead of two, so it's not like the double quote, it's like the single quote. So that defines our text arrays. So as labels, so it's a 1x4 cell. And then if we use the legend command, and the variable we want is labels. So if we do legend labels, go back to our figure, you'll see it has defined our legend with those three states and the US. So there's a couple different ways you can do your legend with line plots. The easiest, if you have kept good track of your data, is probably just to do it from the plot window. But if you like using the command line, you're more comfortable with that, you can certainly do that as well. All right, is everyone still with me after that example? All right, sweet. See, if you go back, I just have some instructions in here on creating that 2D plot that sort of summarizes those different commands that I used, and just sort of a lower resolution example of that plot. But you're free to refer to these later if you want to go back and actually work your way through these. All right, so the other type of plot that I want to show is a bar plot. So bar plots, as most of us know, is a visual tool that uses bars to compare data between categories. You can do horizontal or vertical bar plots, and MATLAB can certainly do both of those. The syntax for bar plots, if you just want to do a regular bar plot, it's simply bar your variable. So here I use X as an example. You can also change the color of the different bars as well. So MATLAB will default to a certain color. If you want to change that, you can. If you want to change it to a certain style, you can also do that. And there's features within MATLAB. You can look up what styles are available. So those kind of change the visuals of the bar plot, but not the data itself. So if you're trying to make it a nice visualization for like a presentation or something like that, those features are available. So I am going to clean up our command window, workspace, and then X out of our figure. All right, and I didn't show it earlier. I'll show it when I do the next figure, but you can save those as well if you want to upload those to like Microsoft Word or a PowerPoint or some other document. For this one, we're going to go back to our import data. I'm going to go to Documents, MATLAB. And then for this one, I'm going to import this C19 cases 2020 0706. So get rid of that. And so this is COVID-19 cases as of July 6th, 2020. Just as a percentage of cases throughout the world, in case you're interested. So this shows a preview of the data. And in this instance, I'm just going to want to pull the numeric values. And I want to exclude this other down here. So you'll see this is the top 10 countries. And then this is the combined percentage of all other countries in the world that this data was pulling from. And as you might guess, this is going to skew our bar graph a little bit for what we're looking at. So I'm going to change our range. And if you want to pick ranges in different columns, so non-adjacent columns, you can just scroll down. Hold on. Do that. And then if you just hold your control key on your keyboard, that you should be able to highlight that. And you'll see when you come up to your range, it's going to say A2 to A11, C2 to C11. Import that as a numeric matrix. And then we're going to import that data. And then you can also change the name. I didn't do it in this case, but you can also change that file name as well if you want your variable to be something simpler. All right, so just to make sure we imported the correct data, portion of the data, I'm going to check this in the command window. So I'm going to type in the variable name. And you'll see this pulled over our data. So these were the numbers corresponding to each of those countries. So like 1 through 10. And then this was the percentages over here. All right, so here we're going to define our variables. Here we just have really one variable to define since we're doing a bar graph, right? So we're plotting each of these percentages. So we're going to define x is equal to C19 cases, 200706. And then here we want column 2. So we want all the row values in column 2. I'm going to type the semicolon to suppress that. Oops, I forgot the last part. All right, so you'll see here, if you get an error message, it comes up in red. So I forgot to put the WS at the end of this. And sometimes MATLAB will do kind of like Google, where it's like, do you need this? And if it does, then take advantage of that. If not, you'll have to go back up into your workspace and double check what your variable name was. But yes, I did mean what MATLAB thinks I mean. All right, so it's defined X, that's now in our workspace. Now we can plot our bar graph. So here, let's define our figure. So this is figure 1. Brings up our figure. So now we have bar, variable x. And you'll see now this has plotted our bar chart. And so you'll see this has, 1 through 10. So I will say with a bar chart, there's not an easy way, at least in MATLAB, to get labels on each of these bars. I've played around with some different things. There's no straightforward way. I just find the easiest in this case is once you plot it in MATLAB, you save it, upload it to another program, and use like text box features or drawing features in those. But it's something I think they're working on potentially for future versions. But you'll see here you can also do your X labels, Y labels, Z labels if you have that, and then a title for your chart. And then as I was mentioning earlier, you can save this if you want as well. You want to import that. You can save that to your storage here. You can save that to your desktop computer as well if you want to work with it. As I mentioned earlier, there's a couple different things you can do with these. I'm going to keep this, if I say figure 2, and say I want to plot the same data, but say I want my bars to be red instead of blue, right? So it defaulted to blue. If I type in the variable x, you'll see within the help screen, it's saying I can do like width, style, color, some more options as well. If I do the single quote, and I say red, so the array value for that is R. So I do single quote R, hit enter, go back to figure 2. Those bars are now red instead of blue. You can also do a third figure and do the style. So say you're looking for something in like a histogram style. There is a histogram command within MATLAB as well where you can plot histograms. But if you're just looking for really something simple that can sort of be extrapolated from a bar graph, if you just say X and then do the single quote hist for that style, you can see that now sort of does that in a histogram type style. That might not be the best style for this particular graph, but that kind of shows you an example of how that works. All right, so before I move on to the final bit, is everyone still good? Everyone still with me? Cool. All right. So sort of in the interest of time, this will probably be the last thing that I demonstrate in MATLAB. We'll talk a little bit about scripts at the end, so you get kind of an introduction of it, and maybe we'll have time to do a quick script. But I also want to show you plotting using the plots toolbar. So if we go back into MATLAB, say clear our window. So we plotted using the command window and using the different commands. You can also use the plots toolbar to plot your data. And to do that, you'll see up here, everything's sort of grayed out right now because we haven't selected a variable yet. But if you just click on this drop-down menu, you'll see there's all kinds of different options for plotting your data, right? We didn't even scratch the surface for everything that's available within MATLAB. So this can be really helpful if you're not 100% sure, what the best way to plot your data is, or what you can do with the number of variables that you have within MATLAB, the size of your data set. This can be really helpful for that. So to get these to actually highlight, we're going to click our variable. So in this case, we just have variable X. And you'll see this gives us the different options that we have. And so you'll see this isn't as large of a list as we saw before. That list was pretty much everything that MATLAB could do. This is showing us what we can do with the variables we've selected. So you'll see we have our bar chart from earlier. We have just a regular 2D line graph. And there's like vertical bar charts, 3D bar charts, histograms, pie charts. So you'll see there's a lot of different examples. But I'm going to click on bar chart since we just did that. And if I click on that, you'll see that MATLAB literally just takes your data, whatever variables you have, and it plots that. So it's plotted this bar graph. You'll see this is the same as we had if I click figure 1 and figure 3, these are exactly the same. So you can use this plots toolbar to help you plotting your data. And if you go back to the example we did earlier where you had X and then the 4 Y variables, you had the 4 lines on each other. There's an option for plot as multiple series versus that first input. So I'm not sure if I can get that to just show up if I go back. All right, so if I do this. So you'll see it's in the grayed out features here. but it'll show plot as multiple series versus the first input. And it'll even tell you when that plot will be enabled. And it says it'll be enabled for 3 or more vectors of the same size. So this will allow you to plot all of those different y variables versus x. So it gives you a nice little help feature as well. And so that's the plots toolbar. So I definitely encourage you to use that if this is, if you're more comfortable using this. If you prefer the command window, please use the command window as well. That's the really nice thing about MATLAB is it gives you different options for working with your data. Whether you're a coding expert or whether you've just used other data analysis programs, if you're just starting out with MATLAB, it gives you a lot of different options for what you want to do. All right, so the last thing I'll talk about briefly is something called scripts. So you'll see everything that we've done so far was just all within the command window, right? We typed out all of our different commands sequentially, one after another. But a script is going to consist of several sequential lines of MATLAB commands. And it allows you to run several MATLAB commands at once. And it's going to be a text file with a .m extension. And you can add comments to provide helpful hints and refresh your memory later. So this is really helpful if you're working with several sets of data and you want to do similar analysis. So if you want to do the same analysis on those different data sets, having a script can be really useful. So you don't have to type in the same commands each time into the command window. So if I clear everything out, make this clean. So to write a script, if you go to the home toolbar, you go to this new script over here on the left-hand side, you'll see this opens up a new text editor. So scripts are essentially text files within MATLAB. So you can type text, you can write out functions, all of that we've talked about today. And to do text, it's really important to put your text in as a comment. So something that's commented out, so to speak, is not going to be used in MATLAB's final calculations when it's trying to calculate all of the functions, all of the variables. So we're going to type in some example text. We're just going to say this is an example script. Today's date, October 20th, 2020. So to comment out text, you can either use the little percentage up here in the top under the editor toolbar. You can also use the keyboard as well. So you can type the percentage on your keyboard as well, and both of them will do that. Here, the comments will show up in green with the little % sign in front of them. And now let's, say we want to define some variables. Say we want to extract different parts of our data like we did earlier, right? So we want to extract different rows and column values from a matrix. So let's say we have B, and we're going to define a matrix A, and we want the value in row 3, column 4. And then in C, we want, say, all the values in column 2. D, we want row 4, all of the column values. And then for our final variable, A, so say we want columns 2 to 3, and all the rows. So we've defined what we want MATLAB to calculate. We've done that all within the script. And then the final comment I'm going to put in there is you can save a script to make changes later, or to come back to the analysis. So say you're doing your analysis right now, you come back to this in like a month and you've done some data collection in the lab or out in the field or something, and you want to do the same analysis, you can pull this script back up and you can run that. And you can save the scripts by going up to this little save icon and saving that to your MATLAB. So if I go into the command window before we run the script and say we define a matrix A, because we're using A as the variable we're pulling from up in our script. So I'm just going to do a matrix real quick, kind of like we did earlier, just to sort of show you guys how this works. Close our brackets. We've defined A. And then to run a script, you can do this a couple of different ways. So one is you can hit the run button up here at the top. So if you hit run, it's going to ask us to save this. So I'll just say example script. So we'll save that. And then if we click save, it should run this. Yes. Save it in the documents folder. So example script, save. And you'll see once we do that, MATLAB has run our script and it has calculated values for B, C, D, and E. So it performed all of these calculations up here all at once. So again, this could be really useful if you have a really large data set. The other way that you can run the script, if you have this up, you have the file name. If you just type in that into the command window, so say example script, you hit enter, and then you can see, since we now have example script here, and then this is our second one. So it ran the calculations here as well. So you can use either the run little arrow icon up at the top, or you can type in the script name into the command window. So that's a little bit about scripts. They can be really powerful for doing multiple calculations, sequential calculations over large data sets. All right, so that's most of what I have for today. We're almost at perfect time, so that's awesome. So I know I threw a lot of information at y'all today, and like I said, this barely scratches the surface of what MATLAB can do. So if you're working with MATLAB and you want to check out some more resources, if you want to play with it a little bit more, some of these links on the screen will provide really great information. If you want to find out more about importing and exporting data, working with 2- and 3-dimensional plots, if you're doing any sort of curve fitting as well, we didn't really have a chance to talk about that too much today. But if you want to, fit curves, there is a way to do that in MATLAB as well. A list of all the different function commands that MATLAB offers. And then if you just kind of want general sort of how-tos, MATLAB has a YouTube channel that's curated by the MathWorks folks, has a lot of really great videos and tutorials, and MIT OpenCourseware, Stack Overflow, and then LinkedIn Learning as well, which is available through Florida State has some really great tutorials. All right. Yes, I just have it right here. A perfect question. So yes, so the slides for today's workshop, I have a bit.ly link here that you can access these. We'll also send these out in an email as well to all y'all. So we'll have that. And then, yeah, this is my contact information. If you have any further questions after today, if you're working with MATLAB and you want to, schedule a consultation or talk with me a little bit more, this is my contact information. Feel free to reach out. You're welcome. Yeah, thank you all for your attention today. Have a wonderful rest of your day.